and Senior Professor of a Department, Professor B.N. Chatterjee, for the support and encouragement. And thanks to our student volunteer Avantika for arranging the webinar. Avantika, could you just introduce our
Hi.
speaker for the day? Yeah,
All right.
thank you.
Wait a second. I'll add maybe last few some.
59 students, good. 59 student teachers.
Avantika, Avantika, could you wait for a moment, please?
I think before Avantika introduces,
yeah.
I believe since Principal Ma'am and Professor Chatterjee is here, it will be wonderful to have some words from them. And they have been present in all the sessions, and it's extremely, we are all grateful and thankful for their encouragement. Of course, thanks to Shoikot for agreeing on a very short notice. But
Definitely.
if Principal Ma'am, if you can please share a few words, and then of course Professor Chatterjee.
Respected Professor B.N. Chatterjee, Head of the Department, faculty and staff members, today's speaker Shoikot Banerjee, and my dear students, good evening and welcome to the special webinar session on supply chain technology and product management. Obviously, good morning to Shoikot.
Morning, ma'am.
Hope all of you and your family members are well during this pandemic period. Today's speaker, Shoikot Banerjee, is an alumni member of this institute. After completion of his BTech from this institute in the year 2010, he had the opportunity to pursue his higher studies in premier institutes like IIM Bangalore and MIT, which I think always is a dream place for every student. And presently he is working in Amazon as senior product manager. So I'm sure this lecture session will be very much beneficial for the participants for knowledge enrichment, and also it will provide an exposure of recent trends used in industry. I'm very happy to find the positive initiative of the department to organize different activities for development of the students, to keep them engaged in a continuous learning process, utilizing this pandemic period. It really deserves appreciation. Also, it's a pleasure for me to see that with time, more and more alumni members are getting associated in the developmental process of the institute, which I think is a very positive sign. And I always believe that alumni members are very important stakeholders and their contribution is very significant. Thank you, Shoikot, for joining us and sharing your knowledge and guiding the juniors. I think this type of exposure is very much required to bridge the gap between industry and academia. Thanks to the department, head of the department, and the coordinators. Special thanks to Shomnath Rai Chaudhary sir for coordination.
Thank you.
And I wish the program to be successful. Thank you.
Thank you, ma'am.
Thank you. I would request Professor Chatterjee, if you can kindly share a few words. His words are always a great source of encouragement to us, and I'm sure you might remember Shoikot during his days. You were here. So, Professor Chatterjee, if you can please.
Please request sir to make video on. Sir, thank you. Sir, always smart.
Sir is.
Okay, thank you, Anurna.
Thank you.
Respected Principal Sudhapa Mukherjee, Professor Anurna Kanjilal, Professor Somnath Rai Chaudhuri, other HODs and faculty members of BP Pordar Institute of Management and Technology, my dear students, and other members who are attending this webinar today. So it's a great pleasure for me to welcome our alumni, Soikat Banerjee, to talk on a very relevant topic today. You see, supply chain management is existing for a very, very, very long years. I don't know for how many, when it existed, but remember it is long, long back. In fact, earlier in industrial engineering and management of IIT Kharagpur, I used to see that they were using the concept of feedback, not in the name of supply chain management, for similar work. But I heard that the word was coined around 1982. And thereafter, this is one of the very important things, and it is being used very, very widely nowadays. Now, the supply chain management has become circular supply chain management because in industry and other areas, but particularly online purchase, sale and purchase, this is very much in use. So it is used not as a linear one, but rather circular one, because in the chain it goes to the actual producer or retailer where it has started, so that it can be reused or modified or whatever it may be. Now, in the present day technology is the digital, first of all, digital technology. After digital technology, its use has been more on the online part. And we find that not only the channel, omni-channel concept is used, not only online, offline, online together, omni-channel mode also, it is very popular nowadays. And the recent concepts, data analytics, predictive analytics, prosperity, and all these are very much in use. I find that IoT has also contributed a lot in the present day supply chain management. And also I have seen that the concept of artificial intelligence, machine intelligence, this has made the thing much more advanced, and it is going on. It is going on, and therefore supply chain management encompasses most of the computer science and technology concepts which are of use nowadays, present day topics. I think our speaker, one of our very well-known, internationally well-known alumni, Soikat, is going to talk in much more detail about some of these aspects. I am sure we are going to gain a lot from his talk, and I again thank Ananya, Somnath, Subhadeep, and others, particularly the student members, for arranging this webinar at the right moment. With these few words, I now request our alumni, our ex-student Soikat, to start his talk, because we are all anxiously waiting for his talk. Thank you very much.
Thank you,
Thank
sir.
you, sir.
Thank you,
Thank
sir.
you, sir.
Questions from you, sir, at the end of the
Thank
session.
you. Yeah,
Thank you.
question
Thank you.
answers we have at the
Yeah,
end of the
we are.
Yeah. Okay,
I'll
Avantika,
start
could
now.
you,
Yeah.
yeah. Shrikant, you can start presenting, please.
Yeah, thank you, sir.
A very good. Thank you, everyone, for waiting so far. We are going to start in a few seconds. Before starting, I'd like to remind everyone to make sure that their cameras and microphones are turned off during the webinar. We'll have a dedicated question and answer session at the end of the webinar, so save your questions for then. If you have any issues or technical difficulties, you can write so in the chat box and we'll check it out. Feedback forms will be rolled out at the end, which is mandatory for attendance. A very good evening to everyone present with us today. I'm pleased to welcome my teachers, my friends, and viewers from other colleges to the webinar on supply chain technology and product management, delivered by Mr. Saikat Banerjee. Mr. Saikat is an alumni of B.P. Poddar Institute of Management and Technology, Department of Computer Science and Management, class of 2010. He has 9+ years of experience in companies like Amazon, Tesco, EA Sports, and PwC. He has led teams from 2 people to 10+ people as their direct manager. He got his master's degree from MIT in supply chain management, focusing deeply into analytics and sustainability in the area of supply chain. He currently works at Amazon as Senior Product Manager, Technical, and is currently designing go-to-market strategies for different products. He is an avid reader and loves playing table tennis. Thank you once again to everyone who is attending today. Without further ado, let's get started with his talk.
Hi all. Good evening, all the faculty. I am going to present. Just a second. Good evening, everyone. Thank you, Professor Chatterjee. I think your introduction of mine, I'm definitely going to let everyone down. What I wanted to say about supply chain, I'm definitely going to get to it. But yeah, I mean, in these like difficult times, supply chain is very, very important. And also the knowledge of supply chain is not that well spread as it is of computer science. And as you rightly mentioned, the intersection of computer science and supply chain is what I sought when I chose the program, and I think it's going to help me going forward, and I hope to share some of the knowledge that I've acquired over the years. Good evening, everyone. It's morning here, so I almost said morning. So good evening to all the students, to all the faculty, and all the panelists who welcome me here. So I would like to start a little bit about myself. I think a lot has already been spoken, but just to set the record straight, I did not get an MBA from IIM Bangalore. I did like a short-term 6-month part-time program called Finance for Non-Finance Executives. That was essentially to learn finance because I was interested in it and I thought I would need it in the job, and I did. And also it would help me in the program that I came in MIT for. So with that out of the way, I would like to just briefly talk about my journey like for 5 minutes. And then I would move into supply chain, then product management, and then question answers. And also I can touch upon briefly on why I chose the master's degree and how I chose it. What did I do to develop myself? So yeah, so a little bit about me. I am right where you all are, students. And I still remember those automata classes by Omlan sir. And also, so I basically graduated from BP Poddar in 2010. Then after that, most of our class went to either Cognizant or TCS. So I was among them. So I went to Cognizant, was there for about like 2.5 years, and didn't really like it that much because I was in the same project doing the same thing. I get bored very, very fast. So I decided to leave. Like I did not have many opportunities and I didn't want to leave Calcutta at that point. So I went to PwC. I learned a lot in PwC in a very short amount of time. In 2.5 years, I developed like really good amount of skills in computer science, essentially application development and system design. And after a stint in PwC for about another two and a half years, I went to EA Sports. I went to EA Sports as a SDE2. I was responsible for game test tooling. So I worked directly with FIFA and NFS teams. I'm pretty sure some of you would definitely play FIFA. So if you play FIFA now, you would know there is a Frostbite engine. And I was behind that engine. Like I was developing things that can be run on that engine. After EA Sports, I went to a small company. I mean, it's not a small company. I went there for only 3 months. It's called NCR. So NCR is the company you would see on every ATM device that you use, or rather say almost every. Then I was developing a small POS application for the retail stores, but I, again, didn't like the job. I moved to Tesco. So I was initially a software architect for a few months, and then I became the software development manager, where I actually learned supply chain management in the real sense of it. So I did some supply chain stuff in PwC, where I was responsible for actually building the digital electric supply chain for India for the Power Grid Corporation. But in Tesco, it was really the retail supply chain that I got, I saw. And then after Tesco, and while in Tesco, I went to IIMB for the finance program that I talked about. And I spent about 3 years in Tesco. Like I learned a lot. And then I decided I want to get my master's degree finally. So I have applied before, but yes, for some reason or the other, I wasn't successful. I was successful sometimes in getting admissions, but not successful in finding the funding. Then somehow some things worked, and then I finally got into MIT. So again, because supply chain, I will come to like why supply chain is so interesting to me. So after the degree at MIT, now I'm working in Amazon. And just to note, like if any runners out there, so I have done 2 10Ks. So I like to run, but I'm like coping with an injury right now. So yeah, I'll get back on the road. Now moving on to what are we going to talk today? So I think I can add the most value if I talk about supply chain in the context of computer science, because that's what I understand. I am not an industrial engineer or a mechanical engineer or a chemical engineer or a production engineer to understand the production lines or how we do logistics specifically. But what I like to and what my interest lies is in the intersection of computer science and supply chain. And it's a vast field and it's growing rapidly now. So if you see Amazon, you don't think Amazon is a supply chain company. You think Amazon is a technology company, but essentially whatever they're doing behind the screens is essentially supply chain to get the product at your door. Next, I want to talk about product management. I'm very new to product management, but I have built some opinions over the last few months and almost a year. And the reason I chose the product management as my next step in career. And also, I want to talk about how to develop yourself to do the things that you like to do. I wouldn't really focus on how to get into a college or an Ivy League school or how to get into US colleges. Like you can find like tons of information if you are really interested, but I would really step back a little and tell you what are the things that you need to do to actually do the things you like, be it being a good programmer in say Amazon or Google, or being going for your graduate degree, or like be a consultant maybe in McKinsey or Bain or BCG. So what you need to develop in yourself to actually do that. And next, I think we should have some time for questions. So I just want to make sure everyone can hear me, right?
Yes, Shoykot, go on.
Okay. So supply chain. Now, as Professor Chatterjee mentioned, like the term was coined somewhere around like 1982. And just to be sure, like I have not really jammed up slides just for the sake of it. I have only 5 to 6 slides, but I would like to talk through it, and feel free to stop me and ask questions at any point in time. Like I don't like for a monologue going on. I would love an interactive session if that's okay with everybody. So supply chain, as Professor Chatterjee mentioned, right? Like supply chain has been there since we know trade. It's probably from the 1000 AD or even before. Even barter system. I don't think we needed supply chain at that point because of the smaller families and smaller areas of people. But as and when trade grew like larger and larger across the world, we had supply chain in some form or the other. But more officially, the supply chain term was coined around 1980s. And since then, supply chain was a very kind of a non-technical soft field, and it is still perceived as that right now, that there are mostly people involved and manual labor involved and maybe trucks involved, and you move products from one place to the other, you maintain the inventory of the products and all those things. But what we fail to understand sometimes is that supply chain is essentially having some goods available at some point in some time. That's the entire crux of supply chain. So you need some product at some point in time, and you need to be sure that that will be available at that time. And that's what Amazon does and does well. And that's what Flipkart does and does well. And any other e-commerce companies or any other retail store that you go to, even the electricity, as I talked about, I worked on a project in PwC, even the electricity in your house is a product of supply chain. So I would like to focus on how a product flows. Now think about it as electricity or the product that you order on Amazon. How does the product flow? What do you do in the system for the product to actually flow? So we go to the system, we select the product, add to the cart, then we proceed to checkout and we submit an order, right? It's pretty simple from the customer point of view. And then something magically happens and the product shows up on our doorstep. Now, I don't know how much of you know about this, but the process behind the screens is just overwhelming. So what happens is, so I've seen this like firsthand at Tesco. So I was working in inventory management, the block that you can see on my screen as like grayed out. So there are several other processes than shown in this screen. This is like an oversimplified version of supply chain management for you to understand. So as a customer, if you go and place an order and your order is approved, there is also a process where your order may be canceled. I don't know if anybody has seen their order getting canceled before it has been shipped. That happens sometimes, but most of the times the companies have like developed their algorithms in such a way that it doesn't happen that way. So you go place an order. What happens is that particular order flows through a team called customer order. It's essentially a list of products that you have ordered and with an order ID. Now, what the customer order team does is they call an API. I will come to the technical aspects of it like after this. What they do is they call a team called order management. Now, by call, I means they don't like pick up the phone and call them. There are APIs and there are services that they call through the systems. Like people don't need to do it manually, of course. So what they call order management. Now, order management checks with inventory management that whether the product is actually available. by availability, I mean whether, say, Amazon or Flipkart actually has the product to sell. If they do not have the product to sell, they cannot sell, right? So they check with inventory management whether the product is available. Now, once the product is available, they intimate the warehouse management team that this product needs to be picked. And then that goes to the transport and tracking team to be shipped. Now, after it is shipped, they track your product and it reaches your home, and then your order is complete, right? But how does inventory management work? Inventory management gets information about whether the product is going to be available or not from several other services. Now, some of the services can be new product induction, which goes to product service. And then through product service, the inventory management knows that, okay, these new products I'm going to sell in the next few months. But what happens to forecasting? Now, forecasting is a key component in supply chain, because when you order and until your order is shipped, many other people can place orders themselves. Now, what happens is, if you do not forecast your sales or your demand, for that matter, your inventory numbers will be wrong, or your availability numbers will be wrong. So if your availability numbers are wrong, then you will end up taking orders from the customer and not fulfilling them, which is like a horrible customer experience. And then that is when you see your orders to get canceled. So what happens is, forecasting does a tremendously important job to actually tell you that, okay, there are going to be 7 orders for the Dove shampoo that is there in the warehouse in the next 5 days. And you make the orders and make the UI in such a way that you don't run out of products. So forecasting is one of the key components. And at Tesco, I used to work very closely with forecasting to get our inventory numbers right. Secondly, as Professor Chatterjee mentioned about omnichannel, right? So what is omnichannel? Now, omnichannel is when an existing sales store, for example, say Big Bazaar in India, they decide to open an e-commerce channel. Now, they have their own warehouses from where the products come to the store at a regular interval based on, again, forecasting. Like, I'm going to sell 20 kilos of banana from this particular store. So I will be requesting for 20 kilos of banana ahead of that time, ahead of my sale, so that I can make the sale correctly, right? So what happens in omnichannel is that when this kind of a system is already in place, like the proper brick and mortar stores, like physical stores are already there, what these companies can do is, if they start an e-commerce service, they can actually ship the products from their existing stores. And Tesco, the place where I actually learned these things, so Tesco, just so you know, it's the largest retail company out of the UK. So being part of the inventory management and leading the inventory management for all the operating regions of the world, Tesco has a huge challenge with the omnichannel proposition, because Tesco has already about 6,000 stores across the world from where they can actually sell products and ship products to customers who are ordering them online. Now, how does Tesco do that? So in an e-commerce scenario, Amazon or Flipkart, they all have warehouses. They all have warehouses from where they can actually pick up the product, ship that product to the customer. But how does Tesco do that? Tesco create those stores as if they were warehouses. And they do the same process without disturbing the existing store customers. They pick up those products from these stores and then ship them to the customers. It's the same process, just a more lucid and more loosely coupled system that Tesco can do, because Tesco already have the real estate infrastructure in place. Now, as I mentioned early on, that I wanted to talk about why supply chain is so interesting to me. Like, I don't want to be the guy who picks up the product and drives the truck and ships the product to your doorstep. I don't want to do that. There are more able people than me to do that. What I want to do is I want to build these systems that helps the people who are actually doing the on-field activities to do it more efficiently. So how I am going to do that? So think about your classes, and I think many people are here are from ranging from first years to the fourth years, right? My question is for the people who are here from 6th sem to 8th sem, people who have actually studied operating systems, people who have studied advanced architecture. I don't know, for us, Professor BN sir took advanced architecture. Yeah, so, and Shenapati sir took the advanced operating systems. Like, those were my favorite subjects while in college, and also automata. So think about it. When you study operating systems or when you study advanced architecture, do you really think of systems that can scale? Like, that's the real problem in supply chain technologies. And also, just putting your algorithmic hat on, think about the systems where you actually put to use your NP level algorithms, like NP complete, NP hard algorithms. That is where supply chain becomes very, very interesting for people in computer science. So what I have mentioned here are just the backbone of the blocks that I mentioned in the previous slide. So each of these blocks in a traditional supply chain company are essentially teams, software teams. What they do, their output is essentially a website. Sometimes for the UI UX people, essentially it's a website or a mobile app. But for all the other teams, these are basically APIs or backend application. I'm pretty sure some of you must have heard of what APIs are. So APIs are some services that you can call to retrieve data. Like, there are several techniques to do that. There is a whole gamut of things when you talk about microservices or the server side of things. Personally, I don't like client side, but my wife is a UX UI developer. She champions client side. All due respect, I do not personally like client side that much. I love server side. Server side is where robust engineering comes to play, right? So when you talk about microservices, what are microservices? Microservices are essentially a very, very tightly bound service which has a one purpose to do and does that purpose very well. And it is very, very decoupled from the other services. The days of SQL are gone. They are just used for very, very small amount of things. I have kept MySQL on top because it is still very much used in the industry, like Oracle or SQL Server, but mostly all the cool teams or all the cool API teams, they do not use SQL. So what microservices essentially does is they create APIs or event-sourced services where when an event happens, I get to know that that happened. For example, just connecting it to our previous diagram, when a customer places an order, that order flows to customer order through a service, through an event sourcing service. So it's an event in the system where that information flows from one team to the other through a service, through a channel. Like, there are technologies like Kafka, the RabbitMQ, like these are all messaging technologies you might want to learn. Sorry, I forgot to mention them here. Like, if you want to develop your career in backend systems or distributed systems or like computer science as a whole, and in this field or in any other, like, I did not come to Tesco with the knowledge of supply chain. I came to Tesco with the knowledge of computer science. So if you want to know computer science, these are the fundamental building blocks of any application development at scale. We are not talking about like a 2-user application. We are talking about an application. So I'm talking about an application where I have like 1 billion transactions a day, like 1 billion transactions there. So it's like there are, and these are all sensitive transactions, because you would not like if you have ordered something and we just fail to process that transaction. What will happen to the customer experience? You would not like if HDFC Bank doesn't process your payment. So these are all like high scale systems with high availability. Now, availability is when you do a transaction. Say, for example, if you transfer some money in from HDFC to SBI in the middle of the night, that will still happen. The regulations in RBI will stop it to flow the other day, but the system will still allow you to actually make the transfer. That happens because of highly available systems. Like there are 99.999% availability in systems. So on this slide, you can see what are the types of technologies that are used in supply chain. And also in other companies, like the supply chain is it's not a niche from computer science point of view. It's niche from order management point of view, from inventory management point of view. It's very unique the way it is done. But from software engineering point of view, supply chain is essentially any other system performing transactions. So if you see the server side, the client side, if you're interested in AngularJS, Node.js, like Node.js is again server side, like React.js, using Express for React or Vue.js, then you can like take your career as a UI developer going forward. But you need to be very, very good at it, because nowadays the UIs are so responsive. Gone are the days when you click and wait, right? You cannot wait. Like I would not click and wait for more than like 2 seconds or something. I mean, if a site is taking, I will just close the window. So that's the level of expertise is required in the industry at this time. And you would be surprised to see the type of work that is going on in India. It's much higher quality than the stuff going on in the US. So if you think about, okay, so after talking about server side and the client side, there's an important component that many of us are interested in this world, right? I mean, in the current world, the field of data science and analytics. It's important, as I mentioned, the forecasting heavily depends on it. So from the supply chain point of view, time series forecasting is really, really important. So time series forecasting is essentially when you have a bunch of data, you decide which data is relevant to me, and based on that, you have algorithms. For example, you have simple moving averages that you take into consideration. For example, you say that, okay, my sales is going to be related to the last 5 weeks of sales. Or you can say my sales are going to be related to the last 1 year of sales. Then you decide that, okay, no, during Durga Puja, we have more sales. So we have some kind of a seasonality to our sales. Or you may say that, okay, these days we are wearing more and more branded clothes. So I would say there is a higher trend to these sales, and these are increasing. So these kind of algorithms come under modeling, where you actually model your existing data to understand what's going to happen in the future. And it's very, very, very probabilistic in nature. It's not deterministic in any way. Secondly, like there are things which you can do understanding clustering. For example, the forecasting team I used to work with, they use clustering heavily. For example, in the UK, there are several clusters of stores based on the background of people who are staying there, income of people who are staying there. Not every store is like a London downtown store. So what happens is, and similarly in Thailand, where Tesco has a good amount of presence, they're also like the Bangkok stores are very different from the stores in the in a rural neighborhood, right? So these kind of things, these kind of forecasting is done after you cluster some of the stores based on other data like kind of geosocial data that you understand how the population around that place is, how much can they afford, what kind of products are selling. So these kind of things. And finally, databases, which is very important. Like if you are thinking about a career in data engineering or just database administration, which is going away slowly because most of us were like full stack engineers. We know databases as good as any database expert, probably not the administration part because most of it is going to cloud. So, and I personally work in AWS right now. So I can tell you like, a lot of these things are going to the cloud. So all the administrative or the tooling kind of work is just going away, and it's for the good. So what you can do is you can start with SQL and NoSQL. So if you start with these and start building like knowledge on these technologies, it is going to actually reap benefits in the long run. So moving on, because I think I'm taking up a lot of time just talking about supply chain, I want to touch a little bit about product management before I move on. So like coming from supply chain, what is product management really? And what we talk about product management when we talk about companies like Google or Amazon or Microsoft. So as I have come to understand, and this is completely my opinion, sorry. So there are two types of product management. One is the inbound product management. That is the more traditional type where the engineers are developing the software. You tell the engineers what to develop. Like they can write the code, but they won't care about, okay, I want to develop an API for availability and I want to focus on 95% availability of any particular product in the store. So that's a product feature. So inbound product management is essentially about how you envision a system and then what features do you think that system should have. And based on that, you build a roadmap and a vision for the product and for the team. And your software team, which essentially, and traditionally speaking, most software companies, every engineering team has one product manager in the team. So they work very closely together. So as an engineering manager in Tesco, where I was like leading a team, I had a software manager, I had a product manager in my team. So she used to define the product roadmap, like what we are going to build and when we are going to build it and why we are going to build it. And the job of my job was to make sure that that roadmap is being followed and is being built by my engineers. For the job of the engineers, which most probably where most of you are going to land immediately in the career, is just building it and building it to the best you can, so that there are less amount of bugs, it scales, and there are some basic hygiene factors to the software. Second is the outbound product management. Outbound product management is essentially you deal with several things. For example, once the product is built, how do you take it to the market? So here comes some of the marketing aspects, but not really, because there are marketing teams to take care of that. But you define again what the marketing team should work on, because you know the product end to end. The marketing team doesn't. The marketing team just comes up with a strategy to go to the customer. But you tell them that this product does this, and you should just focus on this to take this to the customer. So go-to-market strategy is one of the primary things that I am doing right now at Amazon. We perform a lot of customer interviews to understand if the product is actually meeting the customer expectations, and it's very different. Customer experience analysis, which is like after the customer has begun using that product, how do the customer feel? Do they need any more features? Do they need it to be faster? Do they think there are a lot of bugs? Then how can we engage the customer more so that they keep using our product? Like Facebook does this really well, and we are like glued to our Instagram pages, or Facebook for that matter. Like they have probably 2 billion people right now. So they definitely do this very well, engaging and making the product so sticky that you'd be glued into your mobile screen for the whole day. And lastly, like managing the life cycle of the product. Like, how do you really think that a product will be built? The product cannot be built overnight. Like it will take like several development cycles for a particular product to actually be market ready. And even after that, there are like iterations. So as software engineers, you might have heard about the term release. So release is a term when you actually ship a product, or you make a product live, or move it to production. Like these are all same terminologies used in different contexts. I have seen both the consulting world and the like the product management based company worlds. So it's all the same. They just use different terms. So when you manage a life cycle of the product, what you're essentially saying is, what do you think this product should do in its entirety? And you start from the end and work backwards. That is how you get to know that how you are going to develop it, and it's very easy to plan. So yeah, I mean, that's all I wanted to talk about product management. And feel free to drop me any questions at the end of the presentation, or maybe even beyond this event. I'll be happy to answer. So, okay, so before Q&A, I do not have any slide for that. I just wanted to briefly touch about how do you develop yourself for the stuff that you love to do. So, like, truth be told, I was not the smartest guy in the class, and I do not in any way claim to be one. So first of all, you need to know what you really want to do, which took me like 5 years to figure out almost. By the time I moved to EA Sports, then I finally realized probably I am decent enough in computer science, in programming. Before that, I used to think, yeah, I am in Cognizant. What good do I know? Like, okay, I am coding, fine. Like everybody else is coding. People in Google are also coding. What do I know? So that is one of the things that people need to figure out. One needs to figure out what they actually want to do. And after you understand what you are really good at, then, and you would need help from people, definitely, point blank, you would need help from people. I personally did not know that I could actually build end-to-end scalable systems just by myself. So there has been people who thought I could, and they encouraged me a lot. And based on that, I took it forward. So this is my like really a very, very important suggestion to you. You need to know what you like to do. And more than that, you need to know what you are really good at doing. It might be, like in my case, you might be good at something which you essentially don't like to do. For me, that is coding. Like, I can code pretty well, but I don't want to spend the rest of my career just coding. So don't take it in a wrong sense. I'm not encouraging you to not to take a career path that not involves coding, because early on in your career, coding can actually make you smarter. Like that has been proven. Coding can make you logical. Programming can actually make your mental faculties work like nothing else, like maybe like maths. Like if you like, so I have always loved like math sums. I still remember Shubir sir's class. I'm not exactly sure if he's still there in BP Poddar. So I really enjoyed those Lagrangians and Laplace theorems and all those things. but really, like, embrace coding for the first few years, even if you are in a different department in electronics or like electrical. If you can do some coding on your own, there are like tons of material out there. Geeks for One. There are so many other websites like Interview Street, coding, cracking the coding interview. Like, there are so many books around there. Learn coding in a very deep way. Like, you need to learn coding in a way that you can solve problems, not really use some library in Python. I mean, that's not the way like data science should be learned. So I took a course at MIT in AI. I'll tell you, it was brutal. It was just brutal. But if you don't understand the fundamentals, there's no point using some libraries to do a linear regression or clustering or k-means. You need to understand what you're using that library for. People talk about TensorFlow, right? Don't use TensorFlow for the sake of it. Understand what tensors are. What is a neural network? What are you doing in the CNN? If you are like modeling a CNN, what do you want to do, right? So that's very, very important. Secondly, like, if you want to like do your graduate degree, right, in the US or anywhere in the world, one hard truth I found is that you would never know if you get in. I'm talking about good colleges. I'm not exactly sure, because one thing I knew is that I'm not going to apply or spend money in stupid colleges in the US. That's just not the best use of my time or where I was in at that point in time in my career. It's just not a good, from the education point of view as well as from the resources point of view. I don't think that's a very good decision. Once you are in a like good enough college and you choose the field of your liking and you plan what you are going to do in that program even before going there, only then you can actually make the best use of your money. Yeah, if you want to just come to the US for a job, yeah, I mean, you can go to any college and can get a job, right? But I hope that's not what you're taking out of this event, right? Like, I am not here to encourage you to come to US for a job. You can do a job in India. If you really want to do something important, create an impact through a job, why not? But create an impact and actually learn something deeply, then you need to understand what you really want to do. Like, for me, I was the only guy in the supply chain program with a computer science background, because nobody saw supply chain the way I see it. Now I have been able to turn many people in the industrial engineering who wanted to take computer science classes, because I told them that this is interesting and this is how you can actually take your career forward. And digital transformation and omni-channel, these things won't work without computer science. And just touching on the point that SRC sir mentioned in the beginning of the call about blockchain. Sorry, I missed it in my presentation. I just address it now. So I personally don't know blockchain that well, but from whatever I have read and understood, like, blockchain is pretty powerful from a security standpoint. And when you think of all these blocks, right, all these blocks working in tandem, all of these blocks can actually have like a blockchain behind them. Like, there can be a blockchain and all these blocks can actually pass information which is like SHA encrypted and everything, and that can use for tracing back of a particular order. For example, we talked about the flow of order until transport and tracking and until it is delivered to the customer, right? But think about, there are like billions of such orders happening. How do you trace one single order back the entire chain? It's very hard. It's very hard to do in a distributed systems setup. There, blockchain comes to play. How we did it in Tesco, we did not use a blockchain. We had an event ID and a trace ID to all our API calls. So whenever you call one API to another, so for example, the UI is calling customer order, order is calling order management is calling inventory management, right? So these kind of flow always had a trace ID associated with it. So you know which order was called from anywhere in the whole system. So that's where trace is very important, and blockchain seems to solve that problem. But we are still in very, very early phases of blockchain development. And if you're familiar with the Gartner cycle, so blockchain is in the peak, and then it will fall, and then it will stabilize. So check out Gartner's software cycles or technology cycles. I don't exactly recall the name. So it's provided by Gartner, and it has all the technologies which are there in the world right now. So they have a nice map of things, how the technologies evolve from the time they're introduced. So blockchain is in the trough right now. So, but it will again come up and stabilize eventually. So similar with AI and ML, like it was in its peak, and it's called Gartner's hype cycle. So it's basically the hype about a technology. So yeah, I mean, find out what you really are good at and focus on that if you want to do anything substantial. I'm still trying to find out what I want to do in AWS. I still don't know. I am a senior technical product manager, and they're kind enough to let me some time to understand and also find my niche, essentially, like what I really want to do here. And probably I'll take up developer experience in AWS, and it's essentially a supply chain of developers. Like, yeah, I mean, once you know a field to some extent, you can actually make analogies and make connections to other fields, which is super cool. So yeah, I mean, with that, I think I have spoken for far too long, and feel free to ask any questions. I said you can ask questions in the middle of it, but nobody did. So feel free to ask me questions. I'll stop the presentation now, and feel free to ask questions.
Thank you, Shoikat, for addressing my question. I really feel good that you are now much more knowledgeable with that. In fact, I learned a lot from your lectures. So some few questions that others were thinking their questions. One thing, this AWS and the Google Cloud and Microsoft Azure, whatever I know a little bit, they are more or comparable. But AWS is much better because NASA is also hosting on it. That is you can tell students there's AWS certification can be done, maybe with little money and all this. You can tell them, and that is good point. You have said that DBA is not that essential role. That is one good point. And another thing is that the COVID-19 has taught us a lesson. Like you have to be productive from your home also, and a lot of false business issues like lots of business tools and all these things. Maybe next another 1 or 2 years would be irrelevant. So that is one thing. Even without the backing of the US president, Amazon stocks so high, unlike say Tesla. The Tesla is getting the very good amount of government grant, US grant, but Amazon is not getting. But Amazon is picking up. So don't you think this after COVID scare, maybe after 2 years, the supply chain management will be then downside again? Then another. That is just my floating thought. I want your impression.
Yeah. So you are right, sir. Supply chain as a field, it's not really looked upon as a very cool field, right? Like it's not. So that field doesn't attract many people. But I think, sir, the computer science aspects of supply chain will keep growing, and the core supply chain that was evident like in the 1980s or the 90s or until very now, I think those things will actually come down. So more and more things are automated. As you rightly mentioned, like things are going to the cloud. It's very, very. So right now, the entire focus is to reduce human capital to a lot extent, at least the blue collar capital. So so supply chain is going to be there. It cannot go away because we will need our products. But yeah, I think the technology aspects are going to still go high. So
right now it's a peak. Now right now it is a peak. Maybe after 1 or 2 years may lose the peak because everybody has a peak. Right now the supply chain management peak. That is I want to. Yeah, thank you. Let's take other questions. I'll ask you later.
Wonderful, Shoykot. I think it's extremely important that you kept on connecting the cross-section of CS and supply chain. Avantika, can you please take the questions from the chat box?
Yes, ma'am. Okay, first question, we actually got it in middle of the session, but I didn't interfere. It's from Debashish Paul. He asked, Mr. Banerjee, forecasting is the future prediction. Every time it may not be actual. What happens when it goes short or excess?
Yeah, so that's a very good question, actually. So the one thing about forecasting is it's always wrong. But how right it is very, very important. So all the companies, what they do is they always overstock. So there is something called a safety stock, where safety stock is essentially the buffer that a company keeps to actually do, like actually order more upfront so that they don't run out. But they cannot order a lot upfront because that would cost that would like incur some inventory cost on the side of the company. So there's a good trade-off going on. So I mean, there is no right forecast, at least as of now, because forecast is always wrong. So it does go short. It sometimes is in excess, but that's life. That's what happens.
Okay, our next question is by Somyadi Paul. Sir, in supply chain technologies, you put Express.js in micro UI technology, but Express.js is the framework of Node.js and Node.js is used in server side. So can you use Express.js in client side?
So you need some server side code to actually write the UI. So when you are writing AngularJS, if you use Express.js in the backend for just the UI component, the AngularJS would be more robust. Rather than if you just write an HTML with an Angular, it will be very hard to manage that website. So we actually opened, I mean, I recently stopped that website because it was just unnecessarily causing me money. So we opened a software called, like not a software, a website called ratemonk.com. I think the website is still up, but it has no backend connection. So it was entirely written in MeanStack. So MongoDB, Express, Angular, and Node.js. So Express is a server-side technology, you are correct. But when you are using Angular, you need to have a server-side component to render the first HTML index.html page. And it does well if you have that Angular hosted on a Node.js with Express. And that's the reason I mentioned Express in micro UI.
Thank you. Next question is from Nada Ahmed. He has two questions. Actually, I'll say both of them together. First is, how do big companies like Amazon prepare their supply chain for big sales holidays when there's high volume orders in very short amount of time? And he also asked, is the Gartner cycle based on Dunning-Kruger effect?
Yeah, I mean, okay, let's get to the first question first. So how do Amazon or Flipkart prepare like Big Billion Day or those kind of sale events, right? So what they do is essentially, again, they fall back on their forecasting numbers. Like they have so much data about you, you cannot imagine. I personally feel probably Google is listening to us and through our phones. I don't know, like I get weird search results when I search. So I can be sure, like, it's only my opinion, like, that Amazon could be doing as well. But regarding these, I think it's again an entirely forecasting play. Like they do, and it's not a very short amount of time, as you put it. They plan for big billion days for about a year in Flipkart, and this I know for a fact. I have interviewed there in the past unsuccessfully. So yeah, I know it for a fact. For Walmart, for Flipkart, for Amazon, they plan for these high sales. They have dedicated teams for these high sale events, and they plan for it for over a year. So yeah, and for the second question, Dunning-Kruger effect can be actually changed in can be explained in many ways. Probably it can affect on technology as well. The more you know, the less confident you become. I don't know how they do. I have never really checked like their the background, how they do the rankings, but I think mostly it's based on perception and also how people learn those technologies. So there are three things in the Gartner cycle, right? One is word of mouth. Like you talk about AI, I talk about AI. Now the third person talks about AI. Now everybody's talking about AI. Second thing is, are people actually learning AI? And the next thing is, are they really using or really paying money for AI-based services in their day-to-day life? So there are multiple things at play here. And I think it's the adoption cycle they essentially look at and not really Dunning-Kruger effect. Yeah.
Thank you. By the way, as HOD ma'am and Sudeep sir said in the chat, Mr. Saikat will also answer questions depending on like around career advice and stuff like that if you want to study on US and things. So you all are free to ask questions on that. Anyways, the next question is from, wait, let me check. The next question is from Sharuni Das. She asked, sir, what challenges did supply chain officials face during the COVID period and how did they overcome it?
Okay, so the actual supply chain people, the people who are in the field, they really are facing real serious challenges. So the people who are actually delivering our products or working in warehouses, I know for a fact there are a few of my friends from MIT who got into Amazon and they are working in warehouses. So their role is a slightly different role. Like they're called operations pathways manager. So they're essentially managing warehouses. So like the real supply chain people on the field, like they are exposed, like they have to take care, just like the essential workers who are dealing with like the nurses and the doctors. They are essentially they are termed essential workers in the US. So I mean, Amazon, I think, is taking many precautions, but no company is perfect. Like, I mean, I don't exactly know to tell like 100%, yeah, they're safe. But yeah, I mean, they are much more in a riskier position than I am or most of us are. So yeah, they are facing grave challenges.
Thank you. The next question is from Shoumyadeep Paul. He asked, sir, can you please explain the difference between hot fixes and release?
Yeah, so release is so there are different cycles in software management, right? So release is a cycle when you have a planned release, like you are releasing a particular feature for your API or for your website, and then that release is like a planned release, goes to production, goes live, and everybody starts using it. Now you suddenly find there is a bug, and you find a bug in production. So what do you do? So do you really turn that entire thing down and roll it back? No, you don't do that. What you do is essentially you fix that bug and do a hot fix release, which is hot fix release is essentially you just fix a portion of the code and then you release. Now there can be several types of it. Now, if it's a simple bug, you can just fix it and then release it. But what if it's a feature issue, like there is a calculation issue? So if there is a calculation issue, then you're probably going to have another small patch release, which is a little bit different from the hotfix release again. So yeah, I mean, hotfix is just a simple release or a simple bug fix that you push the code to.
Thank you. The next question is, can you discuss how reverse logistics work from supply chain perspective?
Yeah, so it's a great question, and a person who asked this question, definitely you know a little bit more about supply chain.
Nada Ahmed, he already asked 2 questions earlier.
Oh, okay, yeah. So reverse logistics is when you return an item, right? So that's essentially one of the examples of reverse logistics. I can talk extensively about reverse logistics because that's what I did my thesis at MIT on. So I focused on reverse logistics of plastics in supply chain to increase the recycling effect. So in the US, so the US used to export, or rather dump, plastic on China, like from a long time. But and China used to buy those plastics because they create a lot of plastic products. But now from 2018, China has stopped taking plastic from any of the Western countries. So it's a big matter of research here, and I wanted to do something in the area of sustainability, as Avantika mentioned in the introduction. Like, I had a deep focus on sustainability. So essentially, this was my wife's idea. Like, we were once talking, like, how can we really reuse the plastic that we use? But that essentially became like, how can we recycle the plastic we use? And so my research topic developed based on that, where I focused that once we use the plastic, can there be a way where we can actually take back the plastic using the e-commerce reverse logistics mechanism? So to answer the question, reverse logistics is the reverse flow of plastic, as Professor Chatterjee mentioned early on, the circular supply chain model, where you start with the product flows from the manufacturer to the customer, and then there is a cycle from the customer to the manufacturer back, and then the manufacturer can choose to extract some value or the other and then dispose of the product or recycle the product. So this entire process is the circular supply chain, and the process where the product is flowing from the customer to the manufacturer is essentially the reverse logistics.
Thank you so much. We are having a lot more questions.
Next question. To answer. No problem.
Okay. I hope you're glad you wanted an interactive session.
Yeah.
Okay. Next question is by Asasi sir. He asked, can you please compare SAP, HANA, and Salesforce?
Yeah. Sorry to disappoint, sir. I have no idea of the tools. So
that's okay. Just you see, SAP HANA, that is SAP is right now winning Hyperfit, and another is Salesforce. Maybe I think no issue. You don't have to. I think.
Yeah. So basically, sir, just to quickly answer that question, and for interest of others, so these tools are essentially used by most companies. So these tools are used by almost all the companies. Personally, I don't like tools. Rather, I want to create tools. So and that is the reason I do not know.
Okay, great. I think go ahead. Other questions.
Okay, thanks. Next question is from HUD ma'am. It's if you can relate version versus release.
Shoykot, actually students often have this question, like there are release numbers like 1.0, 1.1.
Yeah.
So if you can touch upon that aspect, like
so if you are releasing, so these release numbers are different for different types of applications. So I have worked on both Windows and web applications as well as backend APIs. So So versions work very differently for different applications. So if you're talking about a Windows applications, so there are like 4 numbers, right? 1.0.0.0. Now the first one is the primary release. The second one is I think the secondary or the patch release, and the third and the fourth are like bug fixes. For example, if you see, if anybody uses an iPhone, there are like releases coming like iOS 12.6.1 or 13.6.1. So essentially 13 is the main iOS release, which they release every year. Now this is an on-device application, very similar to Windows applications, so, or Android versions, for example. Then they release like some features which don't go out. For example, for an Apple Watch 5, which they released with the ECG feature, right? So they did not release the ECG feature at the time of the actual release of the Apple Watch. What they did, they actually released it a little later in the form of WatchOS 5.2 point something. Now that 2 is essentially the ECG feature, and 5 is the main release. And the last version are just for bug fixes. Like they find a security issue, they just go ahead and fix that security issue. Like that's the release. Now for APIs, these versions work very, very differently. Now APIs are version 1. Now when you release an API, there are consumers of that API. In an on-device application, the consumer is us, it's you. Now when you have that application on your device, you don't really know, or you don't really care about any compatibility. Because the software producing company takes care of the compatibility issues. So when the next version comes out, that will again be compatible. But think about an API that you release, and that is being consumed by other teams or other applications. Now you have to be backward compatible, because if you release a new version and that doesn't work with the existing version, that their application will fail and they will come crying to you. So there the versions vary differently. Like there you have to maintain at least the last 3 versions, and then you have to deprecate one version at a time. So there the versions are like V1, V2, V3, stuff like that. So yeah,
thank you so much. Yeah.
And Shivashi sir, I like your photo. Tiger's nest.
Okay, the next question, this is not a technical question. This is from Reema Day. She basically asked that if an individual is interested in a field but they are not skilled in it, and at the other hand they have a field in which they are skilled at but not interested in, how do they choose between the two things?
I think it's extremely important. Yeah. Shoikat, please go ahead.
Yeah, that's a very hard question actually. And it takes time, like, first of all, no companies will hire you for your interest. They would hire you for your interest if you're good at your interest. If you are not good at what they are looking for, they're not going to hire you. Having said that, it is easy to actually learn if you are interested in something. I was interested in like building systems, so I could learn distributed systems quite well. I did not do that well while actually learning advanced architecture in college, but I learned it afterwards when I really needed it. So yeah, I think if you're interested in something, like spend time reading about it, take courses. Like right now there are so many avenues, right? Like there is Coursera, there is Udemy, and these avenues are even cheap. Like if you are just focusing on like knowledge, right? Like you can just enroll as an auditor in Coursera or EDX courses. You can like learn from there, and you can develop your skill. But yeah, if you're looking for like certifications to prove to the company that you know stuff, that will cost you money. But more often than not, you don't really need that. So a good way to do it is in your current company, wherever you join, in your current company, seek the roles that you want to pursue. And if you're not getting them, ask people that why and what can you do or what can you learn to actually get those roles. Yeah, I mean, of course, if you're a software engineer, I don't know like many people who would suddenly become the HR person, right? And if you want to become the HR person, your path of action would be, okay, step back, take and do an HR MBA and then go back to become the HR. But if you are in, say, software engineering and you want to do some analytics, then you can, I think it's possible to find your way within the company, provided you have the knowledge. And to build the knowledge, ask people, and also like read up on stuff. Like the best way to do is reading up on stuff and doing online courses, at least for knowledge building. There's like ton of resources. Just search on Google or search on YouTube. You'd be like overwhelmed with the amount of resources available.
Thank you. The next question is from Nada Ahmed again. His question is, how different is the supply chain for prime customers who get faster delivery and one-day delivery?
I am not exactly sure how different it is, but I think the mode of transport is different. But the rest of the components, as I mentioned in that block diagram, right, the rest of the components are essentially the same. But I know for a fact that there is a separate prime operations team who actually work for the prime customers. So, but I don't know the exact mechanics behind that.
Okay. The next question is, sir, can you, by Swaraj Khan, it is, sir, can you please tell some trending technology areas to work on for those who want to start their career after the COVID situation?
There are many trending technology areas, right? I mean, trending as in, yeah, I mean, whatever is not ancient is trending. Like, I mean, for me, if you are good in problem solving, if you do, I mean, I learned this the hard way. I did not know while I was in college that there are competitive programming websites and people actually do competitive programming. So if you are good with competitive programming, you're going to find a good job in the product companies like Flipkart or Amazon or Snapdeal or these kind of companies. So it's good if you learn data structures and algorithms very, very well, like really well. Like you can do like like red black tree parsing and problems based on that, or you do basic graph based and then you break the graph into a tree and then do some DFS on that. Like these kind of questions are asked. I have seen in interviews, I have done interviews. So I used to do like university interviews in Tesco, in all the IITs and the BITS Pilanis and these colleges. So these questions are important. I did not know this in college and I learned it the hard way. It's a funny story. So yeah, I mean, you can practice stuff on Geeks for Geeks, and from the technologies point of view, technologies keep a very, so learn technologies not for the technology's sake, learn the fundamentals, how those technologies work. So because technologies are changing so fast that you cannot keep up with all the changes that are happening in the, so if you see the last 6 to 7 years, GitHub has exploded, or NPM has exploded with packages. But is it humanly possible to even understand those packages and use them at a regular basis? No, absolutely not. But you need to know how any package manager works. So you will be able to use NPM, you will be able to use Maven, you will be able to use NuGet. Like this is .NET, Java, and Node.js. So you need to know how package managers work, how packages work, why there is a need for packages. So these kind of fundamental things are very, very important, and you have got all the time in college to do that. I didn't know all these things at that time.
Okay. Thank you. The next question is from Debanjan Day. This is on continuation of your answer on reverse logistics. He asked, did focusing on reverse logistics help in reducing environmental concerns about plastics? If yes, how?
Yeah, of course. So if you are taking back plastics from the customers and sending it back to the recycling plants and then sending those recycled plastics to the manufacturers, so the manufacturers now are using recycled plastics in manufacturing regular products. Like I worked with consumer packaged goods companies, for example, Colgate Palmolive, or like P&G, Procter and Gamble, and there are like many other companies like that. So they use like shampoo bottles and whatnot, hand soaps and those sanitizer bottles now. So these are all created from plastic, right? So when they have more and more recycled plastic, they reduce the usage of virgin plastic. Now, virgin plastics are essentially the plastic which is like raw from petroleum. So if they stop using, and if they reduce the usage of like virgin plastic, and like rely more and more on recycled plastic, definitely the overall plastic usage reduces and the overall plastic waste comes down. So yeah, the answer is yes.
Thank you. The next question is from Nada. Again, the question is, do engineers actually implement advanced data structures like aerial trees and RB trees in their jobs?
It depends on the teams you're working, but you would definitely need these for the interviews. So even though you will be working on stupid APIs after getting the job, but you won't get the job if you don't know these for the interviews. But there are teams where they do use trees. At least I know for a fact, because I work with the search team very closely. So enterprise search, or any type of search for that matter, uses tries. Do you know what a try is? I'm sure you have read that in your advanced algorithms course, because I did. So the tries are very, very important for searching. And then hash tables, like from tries, you can actually create a data structure using hash tables to make very, very fast searches. And there are technologies, for example, I think Lucene, which works behind Elasticsearch, and Elasticsearch heavily uses these things. So yes, you do use some of these things. I have been involved in some data structure development in Tesco using, when I was like, it was not really data structure development, rather an algorithm development. So if you are creating a new algorithm for any particular feature, you would think about what data structures to use to actually create that algorithm. So it's very, very important to have those fundamentals sorted right here in college, because later on you won't get the time, and you would spend like a lot of sleepless nights if you want to get ahead. So I have been there, I have done that. So I'm telling you, like early on, don't waste these 4 years.
I mean, he and I are in fourth year, which is kind of...
Okay, so then if you think that you wasted all the 3 years, then you still have 1 year to...
You see his questions. He clearly hasn't wasted his 4 years. Okay, the next question is from Anirban Shaha. He asked, what is more important, being a good developer or being a good coder?
I don't understand the difference.
I guess he meant coding as in a competitive coder, and developer as a product developer in general, maybe being good at writing back-end code or front-end code.
Oh, okay. So I think being a software engineer is very, very important. Like, don't learn the libraries. They are stupid. You can Google them. Nobody cares about libraries. Think about coding as, if you were asked to write code on a piece of paper, would you be able to write it in the simplest of forms? Think you don't know the knowledge of any libraries. For example, if you have to reverse a string, you cannot do a dot reverse or a dot swap or anything like that. But you have to reverse a string, you have to reverse it using a for loop. Think about a string as like a array of characters, like in C. So that is why many competitive developers or competitive coders, they use C++ and C to do programming. And I know for a fact I didn't do that. There was a friend of mine in Tesco. He used to use just a notepad to write his production level code. He did not use any IDE, no JetBrains, no Visual Studio, nothing. Like plain text pad. So
thanks so much, Shoykot, for highlighting the need for basics and fundamentals. Absolutely important for students who are there still in college, as you mentioned. They have still time.
Yeah, I mean, I have been in interviews at Microsoft, at Flipkart, and these places. I have seen like these things happen a lot. So in Microsoft, after solving like almost 3 rounds, I was rejected because they told me that I did not write clean code on paper. Like I had a lot of scratches in my code. And
oh my goodness.
Yeah. So
that's
that
a
is very,
big
very,
lesson learned. Yeah.
So
yes, I think that's a very important point, because this is exactly what I find when we are doing programming in Java, the Java lab, or even in the class. They always, specifically in the lab, they always intend to use IDE. Even if I insist on writing in Notepad and just using the JDK.
Because of code complete, sir.
yes. So that's quite a struggle, and they never would like to, compromise on that part.
Yeah, all the top companies will actually make you write code on paper. So or the whiteboard. So if you have to be prepared for that, you need to actually know most of the things. So I can tell you what were the questions that I was asked in Microsoft. So in Microsoft, they asked me to do a zigzag breadth first search traversal of the tree, of a binary tree, but as in a zigzag manner. It's not like this, but it's like this, right? So you need to use like a queue and a stack along with the tree to do that. So and the other question was I think spiral printing of a matrix. So you need like 4 different, and you have to do it. So, and there is a huge time constraint. You cannot be like O of n cube or something, right? So you have to do it max O of n. So you cannot go beyond that. So yeah, those things are very, very important. Like the fundamentals are, I mean, I learned it the hard way, and I hope you guys don't. So
yeah, that's something coming so honestly from you, and I think that is going to impact them, because coming from a senior who is already established, who has found his career path, and who has been sharing with you all throughout. So I'm sure this has been an excellent session. So Avantika, do we have any more questions? I believe we have taken up full 2 hours of Shoykot's morning. He had been kind enough to be with us. I wish we could have a hot cup of coffee for him.
It's an honor, ma'am.
Yeah, but
no, it's really nice.
Avantika, may I get a question? Put up a question? Not a question. Yeah.
Yes,
yeah. If we don't have further questions, I think we'll end with SRC sir's question.
Yes.
Question and answer, which he'll answer himself, I believe. Yeah.
No, that's okay. It's great that you have given a great lecture. Actually, whenever I come to this teaching profession, I also, everything I taught, everything I learned from himself. I am fully supportive that nobody can learn it from the 4-year class too. That I want to maintain. I wish to support you. It is not possible, even teaching, and whenever you are passing out in 2010, I just want to, at that time AWS not there, not that time the CodeChef and all these things is not there. But right now, probably students would agree. We try to impress with them to put some hackathons, and they are now 1 year after another they are winning. And this time also, one team or two teams are there.
2 teams are going on.
Teams are there, and there are a lot of ideathons and other.
In fact, SRC sir had been instrumental in motivating them, and the culture is there now in college.
Vikramaditya sir is there. The people are. We have changed. We also try to change, but it is really a good thing. You tell this, it is from you the student would believe. I am also telling red black tree, but the problem is red black tree is not in the syllabus. I told you the red flag tree is there, but it's not the syllabus.
Forget about the syllabus.
It is not in the syllabus.
Forget about the syllabus.
Yeah, but I am happy. I try to happy.
Yeah, sir, you're totally right. But I would just like to add one more thing.
Yeah.
And that is like so what I learned in BP Poddar is beyond what you were mentioning right now about code share for that. But what I mentioned is essentially the appreciation of what I learned came to me much later in my career. Rather than my immediate career. So the concepts on pipelines in advanced architecture, the concepts of cache management in advanced architecture, the concepts of conflicted like critical section accessing in operating systems. So these become so important in distributed systems kind of designs, is that I came to appreciate those things like much later than almost immediately. And I just hope the students who are current students now don't do that. So that's all the hope, and that's all I want to get out of this.
Yes.
Definitely.
Absolutely.
Yeah. Probably my question is not finished. I am just another thing is how this hacking by the government support, like openly like China and Russia, how this e-commerce can handle this this one question. How are preparing oneself, your e-commerce site can be protected from this? Till now, maybe hacking attempt not there. Maybe the Alibaba is there because the Chinese businessmen are also there in Facebook and all these things. The other thing is, what is the quantum computing? Quantum computing is now proven. Within 2-3 years, it may come as a commercial service. API service is coming. So how your supply chain management will get hold of
So what did you mention? Sorry, I missed that part. What is that content?
First part is hacking. Hacking into your system by like North Korean, that they have tons of engineers, thousands of engineers, BTech engineers are on a government role to hack the sites and hack the sites of the nation at a time. That is already proven in China. It is there. It is North Korea. It is there. Probably America is also there. They are not agreeing. So how to protect this kind of site? This is question number one. So that any individual, your e-commerce site like AWS has to be protected from this gangs of cyber criminals supported by not like your Bihar is this what is that criminal gang, not that. It is a government. It's a government. It's a cyber war basically. That is one thing. And second question is, what is the quantum computing? Quantum computing is already there. Google is already coming 53 qubit, and IBM also coming. So they might have some role in supply chain.
So to address your first question, sir, I think security is very, very important for any system right now. So there are several mechanisms of security in place at the enterprise levels. For example, if you think about like basic user ID and passwords, right? If somebody creates a startup, how are you going to encrypt your passwords? Like there are several mechanisms, like one-way hashing is a mechanism, like bcrypt, you can use like bcrypt algorithms, or say SHA. Even SHA 256 is a good algorithm which cannot be broken. There are concepts about rainbow tables and all those things where they have already tried to match. So how it works is, for passwords, how it works is, when you enter a password, it is hashed and saved in the database. Now you come to the site and you again enter your password. It is again hashed, and then those hashed are matched. So the passwords aren't matched to each other to say that the login should be successful. The hashes of those passwords are matched, and then the login becomes successful, right? But there are several other mechanisms from the network side of things which I don't know very well, but most of the time the sites which are like HTTPS protected are fairly protected, I would say. And the hackers who are like in play mostly hack through social engineering means. Like, for example, they would give you like phishing links or those kind of links where you can actually click, and probably from your cookies they would extract information. So that is possible. That used to happen in the Orkut days. if anybody here even knows about Orkut. So Orkut used to be a social networking site before Facebook. We used Orkut extensively while in college. So, so Orkut could be hacked through the cookies. So that was, and that could be hacked on Mozilla through Grease Monkey like add-ons. So those things are there, but these days security is also improving in like many aspects, like secure socket layers. Then there are like different types of firewalls and securities, like even DMZs, right? The DMZs, the firewalls are very, 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 very strong these days at an enterprise level. So, but I am not a networking guy, so I don't know the networking based attacks that happen. Like, yeah, but there are serious attacks that go on, like DDoS attacks, like distributed denial of service attacks that happens. Even Google has faced that attacks, and they could not do anything about it rather than change their availability zones of those applications and then like change the parameters of their application. So those attacks are always there, but yeah, what to do, sir? And
thank you very much. Yes, yeah. Thank you very much.
The second question is about quantum computing. Again, sir, I have not really delved much into that because it's not really in direct intersection to what I do. So I do not have much idea about it.
Okay, that's great. Maybe AWS, Amazon will should surely come because Google.
Yeah, they will do it, sir. They will do it only when it's profitable. Amazon doesn't do anything unless and until a customer can be used. A customer can use it.
Yeah. Yeah. Anyway, very great lecture, and really, I think.
Thanks.
Shoykot, excellent lecture. Thank you very much.
Thanks so much. Thank you so much, Shoykot. I would request everyone to turn their camera on to have a snap and a huge round of applause for him, for Shoykot.
Hello, Amlan sir. How are you?
Hello. Fine. Excellent session, Shoykot.
Thank you, sir.
It's always a proud moment.
Not to antagonize with any other faculty. Omlan sir has been my favorite faculty. So
it's absolutely a proud moment for all of us. You know that.
Yeah. It's an open disclosure.
We are proud of you.
Also loved Omlan sir's classes.
Thank you.
Still they are. I'm sure.
Even the current students do so.
Yes, sir.
Yeah.
Absolutely. No doubt about it. Okay, so thank you once again.
Yeah. Good night, everyone.
Thanks to Shubhodip. Yeah, good night. Good morning to you. Yeah. A weekend. You had recently moved, in fact, so Shoykot had to adjust a lot of things and still come up with this session.
Shoykot, can I request one thing? I believe you have shared your slides or your contact information by email. So can we share it with our students?
I can share the slides, but I don't think that will help anybody. But yeah, I can share the slides. That's no problem.
I was talking about your email ID so that any of our students may contact you regarding any queries further if they have.
Yeah, sure.
Yeah, please. Okay.
Thank you, Shubhodip and Avantika. I think Shatu is there with you, Avantika, for organizing.
He's not there right now, but he helped us organize.
He helped. Okay, so thanks to all of you for doing it at a very short notice. And we'll be again meeting back next week with another alumni webinar. So all other students, please stay tuned, and thanks once more before signing off. Shoykot, have a good day.
No problem.
And stay safe.
No problem.
Stay safe, everyone. We will keep connecting back. Yeah,
sure thing. Take care.
Bye.
Goodbye.
Bye.
Everyone, please make sure to fill the feedback forms.